Oh, no, there we go. Performing a hypothesis test. Today we're just going to focus on the p-values. So what you guys learned the last lesson is when you perform a hypothesis test, you can either look at the critical values in your test statistic, or you can look at the p-value, and it will be the same every single time. But today we are going to have a specific emphasis on just looking at the p-values. Okay? So it says if the computed p-value is less than alpha, reject the null, and if the computed p-value is greater than or equal to alpha, fail to reject the null. There was that little friendly little quote that the video talked about, and it said, if p is low, what happens? The null must go. Very good. If p is low, the null must go. If p is high, the null must fly. Very good. If p is high, the null must fly. Okay, that is all we're going to focus on this lesson. If p is low, the null must go. If p is high, the null must fly. That's all it is. Okay, so let's look at number 1. A manufacturer of banana chips would like to know whether its bag filling machine works correctly at the 432 grams setting. It is believed that the machine is underfilling the bags. A 24-bag sample has a mean of 429 grams with a standard deviation of 10. Assume the population is normally distributed. A level of significance of 0.01 will be used. Find the p-value of the test statistic. You may write the p-value as a range using interval notation or as a decimal value rounded to 4 decimal places. So the very first thing we're going to do is we're going to write down all the different information they gave us. Okay, so first and foremost, we need to figure out our null hypothesis. What is our null hypothesis here? Are we talking about mean? Are we talking about proportions? What are we talking about here? The mean. And what mean are we focusing on? 432. Your null hypothesis always has to use what symbol? Equals. So our null hypothesis is that the mean is going to equal 432. The mean is going to equal 432. Okay? The alternative hypothesis is where we have to do a little bit of thinking. So the alternative hypothesis is still going to be the mean, but did they specify like how they think it's actually doing? Overfilling, underfilling, or just different? It specifically said underfilling the bags. So my alternative hypothesis, we think the mean is underfilling, so less than 432. Okay? Now, from this problem, let's figure out other information. It's believed the machine is underfilling the bags. A 24-bag sample, what does that mean? What's 24-bag sample? What variable? N, so my N value is going to be 24. Has a mean of 29 grams. What does that mean? Very good. That's your X bar because it's your sample mean, 429, with a standard deviation of 10. Notice how that standard deviation is in the same sentence as the X bar. They are saying you have a sample, it has a mean of 29 grams and a standard deviation of 10. So is that going to be population or sample standard deviation? Sample. So that's going to be my S value. That's going to be my S value. Okay? And then it says, assume the population is normally distributed. They have to tell us that because it's not greater than 30. A level of significance of 0.01 will be used. What does that go in for? That's going to be my alpha. Very good. So 0.01. So all of this information, oh bless you, all of this information we have to figure out which of our templates we want to use. Guys, these templates are a gift to you. You get to use them on your test. Okay, they're doing the work for you. You have to know how to read it. So first of all, let's look at this guy right here. We're talking about a mean, okay? So we know that we're going to use one of the mean templates. But based on my alternative hypothesis, is this going to be a one-tail or two-tail? This is a one-tail. How do I know if it's going to be two-tail? What would I see? Yeah, you would see does not equal. Very good. So this is a one-tailed test, a one-tailed mean. okay? And is it going to be sigma known or sigma unknown? Sigma unknown. We only know S. So let's go to our templates, and we want one-tailed mean sigma unknown, okay? One-tailed mean sigma unknown. So I'm going to look here, if I can find my mouse. There it is. Here's one-tailed mean sigma unknown, and we want to highlight the whole thing, title included. Title included. Highlight the whole thing, Control-C, copy it, and we're going to go back here, and we're going to paste it right in there, Control-P. Not Control-P, Control-V. Golly. Okay. I did say unknown. Did I highlight the wrong one? I sure did. Should be sigma unknown. Very good. One-tailed mean sigma unknown. Good catch. Thank you. One-tailed mean sigma unknown. Thank you. Now, we only put in the information in red, okay? So significance, X bar, mu, S, and N. We only put in that information. Everything else is filled out for us. So what is my significance here? 0.01. Good, that's my alpha. What is my X bar? 429. What is my mu? 432. Very good. What is my S? 10. And what is my N? 24. All right. So just a quick refresher of what we learned last time. We learned last time about the critical values. So if like I wanted to sketch this out, the critical values were at negative 2.5 and positive 2.5. And this is a left-tailed, because it's pointing to the left, this would be left-tailed. So anything to the left of it would be in the rejection region. And since this test statistic is negative 1.5 right there, it would be in the fail to reject region, right? But this guy right here, we only want to look at the p-value. So my p-value is 0.078, 0.078. And my significance level is 0.01. My significance level is 0.01. So tell me, is the p-value lower than the significance level or higher than the significance level? It is higher. The p-value here is higher than 0.01. If p is high, the null must fly. So there is significant evidence to support my null hypothesis. However, that's not even what they're asking. Okay, let's answer the actual question. It says find the p-value of the test statistic. You may write the p-value as a range using interval notation. We don't have to do that. It's only a number. Or as a decimal value rounded to 4 decimal places. So I'm going to come here and I'm going to say my p-value equals, and you can just do a cell reference if you would like, but make sure you round it to the 4 decimal places like they asked. 0.0776. Okay? Number 2, the director of research and development is testing a new drug. She wants to know if there is evidence at the 0.05 level that the drug stays in the system for more than 393 minutes. For a sample of 74 patients, the mean time that the drug stayed in the system is 395 minutes. Assume the population variance is known to be 529. Find the p-value of the test statistic. Round your answer to 4 decimal places. So this is the same concept as what we did on number 1. So what I want you guys to do is take a minute, and I want you to find all of the information and write down all of the information that they gave us. Then we'll come back and share the information and decide which test to use together. Okay, so from this problem, I got my null hypothesis to say that mu equals 5.8. Do we agree with that? Nope, I wrote down the totally wrong problem. Hold on. All right, let's try that again. So from the problem, I got my null hypothesis to say that the population mean is 393. Yes? And then it says she wants to know if there's evidence at the 0.05 level that the drug stays in the system for more than 393 minutes. So that means my alternative hypothesis is going to be mu is greater than 393, okay? Then she chose a sample of 74 patients. She got a mean of 395, so that means that my X bar is 395 and my sample size, which is 74. And then it says, assume the population variance is known to be 529. So I put in here variance, but what symbol represents the population variance? What did I really find here? Sigma squared. Sigma squared. And that means my alpha is 0.05. So tell me, if I know sigma squared, do I know sigma? Yes. Okay, so on this example, sigma is known. Now, some people choose to come down here and say sigma and go ahead and find the square root of 529, and they choose to have that math or have that answer in their list. That's okay if you would like to, if that helps you, okay? But I'm also going to show you how to do it in the actual table. Now, let's figure out what kind of table we need. We know it's going to be a mean, but tell me, according to my alternative, is it one tail or two tails? This is going to be one-tailed mean, sigma known or sigma unknown? Sigma known. So let's go to my templates, and again, I want one-tailed mean, this time sigma known. So one-tailed means on this side, sigma known is the top one here. Copy the whole thing, title included. Paste it in there. Now we're just going to put in our information. My alpha, my significance level, we said was 0.05. What is my X bar for this problem? 395, very good. What is my mu? 393. Now, sigma, you can do one of two things here. Here you already have sigma figured out, and it's a really nice number, so you could just do a cell reference or equals 23. But sometimes, and you're going to see this on your homework, you're not going to get a really nice number. Maybe they said the variance is 530 instead of 529, which means it's going to be a gross decimal. So if you want, you can come in here and put equals the square root of 529 right in there, and it will give you the exact. So if it turns out to be like 23.121 or like a really long decimal, you can have it right in there by just doing that formula. And then what's my n value going to be? 74. Now again, with this problem, they only want the p-value. They said find the p-value of the test statistics. That's all they wanted. So my p-value here equals, and I want this cell reference, and again, they want it rounded to 4 decimal places. Okay? Now, can you guys tell me if my p-value is 0.2272, is p low or is p high? P is high. 0.2272 is greater than, oops, come on. Well, my pin's not working now. But it's greater than my significance level of 0.05. So, if, are we having this game today? What is happening? You guys see the kind of day I'm having? So since the p-value is higher than the test statistic, or than the significance level, than my alpha, the null must fly. Okay? P is high, the null must fly. Let's go to number 3. Our environment is very sensitive to the amount of ozone in the upper atmosphere. The level of ozone normally found is 5.8 parts per million. A researcher believes that the current ozone level is not at a normal level. The mean of 25 samples is 6.1 parts per million with a variance of 1.21. Assume the population is normally distributed. A level of significance of 0.05 will be used. Find the value of the test statistic. Round your answer to 2 decimal places. So, my null hypothesis. My null hypothesis. What do we think? Mu is equal to 5.8 parts per million. Very good, 5.8. Okay? Now my alternative hypothesis is still going to be mu, but what do we think this time? Yeah, it says it believes, the researcher believes that the current ozone level is not at a normal level. Did it say greater than or less than? It literally just said not at. So that means that it's not equal to 5.8, which right off the bat tells me what kind of test is this going to be? A two-tailed test. Very good. Okay, now let's put on all the other information. So my N value is what? 25. That was my samples. Okay. What about my X bar? 6.1 parts per million. Very good. And do we know sigma in this problem? No. So what is 1.21? Tell me. The sample variance. That is the sample variance because it is in the same sentence. It says the mean of 25 samples is 6.1 with a variance of 1.21. It's talking about the sample. Okay, and then finally, do I have my alpha? 0.05. Very good. All right, so we already said this was going to be a two-tailed mean test, but is sigma known or sigma unknown? Sigma unknown. So let's go to our templates. Two-tailed mean, sigma unknown. So two-tailed mean right here, sigma unknown. Now, we already have the significance level of 0.05. That's great. What's my X bar? 6.1. What is my mu? 5.8. What is my S value? How am I going to find that? Very good. Equals square root of that 1.21. And my N value? 25. Now, this question was specific. It just said find the value of the test statistic. So the test statistic, rounded to 2 decimal places, it's going to be equals, and then you have to find where it says test statistic right here. It's this guy right here at 1.36. And again, 2 decimals. Now, just a reminder, I spelled test wrong. Just a reminder on what a test statistic is. That means if I were to actually draw my distribution here, and I have critical values of negative 2.06 and positive 2.06, and that gives me my rejection region. The test statistic is 1.36, so here's 0, 1.36 right here. And that is in the region that we fail to reject. So this would mean we fail to reject the null hypothesis. Okay, we fail to reject the null hypothesis. All right, let's go down to number 4. Again, all we're doing today is just getting some practice with this. That's all it is. Number 4, an engineer has designed a valve that will regulate water pressure on an automobile engine. The valve was tested on 130 engines and the mean pressure was 4 psi. Assume the population standard deviation is 0.6. If the valve was designed to produce a mean pressure of 4.1, is there sufficient evidence at the 0.1 level that the valve does not perform to the specification? So go ahead, take a minute, and write down all the information that you can find. Okay, so I found that my null hypothesis is that mu is going to equal 4.1, and this one specified that they thought it was just going to be different. Okay, they just thought it was going to be different. So they didn't specify greater than or less than, so it's just going to be not equal to. Tell me what kind of test does that mean we're going to have? Two-tailed test. Very good. Now, I got my samples sized, or samples, number of samples to be 130. My X bar is 4. Sigma is 0.6 because they said assume it is known. Assume the population standard deviation is known. And then at the 0.1 level, so that's my alpha. So we said two-tailed mean, and is sigma known or sigma unknown? Sigma is known. So two-tailed mean, sigma known. Let's go ahead and copy that template. Two-tailed mean, sigma known. Whoa, sorry about that. Two-tailed mean sigma known. Then we're just going to put in all of our information. So what is my significance going to be here? 0.1, very good. Be careful, that's 0.1, not 0.01. Okay, be careful with those zeros. What's my x bar going to be? 4. What's my mu? 4.1. Sigma, 0.6, very good. And my n value, 130. Now, this question was very specific. It says, assume the population standard deviation is 0.6. If the valve was designed to produce a mean pressure of 4.1 pounds per square inch, is there sufficient evidence at the 0.1 level that the valve does not perform to the specification? So when you do a problem like this on Hawks Learning, you're going to have two options here. Okay, so I'm going to type them in over here so you guys can see. You're going to have two options. The first option is going to read, there is sufficient evidence to support the claim that the valve, does not perform to the specifications. And then the second option is going to be almost the exact same, except it says there is not sufficient evidence to support the claim that the valve does not perform to these specifications. Wow, specifications. Good. So those are going to be your two options, and you're going to have to make the choice depending on what information you see from your table, okay? So on this table, we're going to look at the p-value. If you want to look at the test statistics and like compare it to the critical values and see if it's in the rejection region or fail to reject region, that's okay. Or we can just look at the p-value. P-value is 0.057. Is that greater than or less than my significance level? Greater than or less than my significance level? It's less than. So the p is low. Remind me, if p is low, the null must go. That means I've got this guy right here. It's out. That doesn't work for us. But what does that mean for my two options? Okay, what does that mean for my two options? Well, my alternative hypothesis said that the mean does not equal 4.1. The mean does not equal 4.1. They didn't tell me what the mean does equal. I don't have to figure that out. I just have to know, did we figure out if the mean is equal to 4.1 or not equal to 4.1? And we rejected the null hypothesis. So we're sticking with my alternative. That means there is sufficient evidence to support the claim that the valve does not perform to the specifications. Does that make sense? We don't know what it does perform to, but we have enough information to say that it doesn't perform to the specifications that they gave us. Are we okay with that? Those are the types of questions you're going to be answering today. The p-value, the test statistic, figure out if there's sufficient evidence or not. Okay? Let's try one more like that. So number 5, and then we're done. A manufacturer of chocolate chips would like to know if her bag filling machine works correctly at the 419 gram setting. It is believed that the machine is underfilling the bags. A 26-bag sample has a mean of 413 grams with a variance of 529. Assume the population is normally distributed. Is there sufficient evidence at the 0.05 level that the bags are underfilled? So let's take a minute and find our information. Okay, so my null hypothesis, what do we think? Mu equals 419. What about my alternative hypothesis? Mu is less than 419. Very good. That tells me right away what kind of test is this? One-tailed test. Good. What is my n value? 26. What is my x bar? 413. What is, they gave me 529. What is that? Sample variance. So that's going to be my sample variance. And we said that is 529. And what is my alpha? 0.05. Okay. So we said one-tailed test, and is sigma known or not? No, sigma is unknown. So let's find that template. One-tailed test, sigma unknown. One-tailed means sigma unknown. Okay. Put in your significance level. Oops. What is my x bar? 413. What is my mu? 419. How am I going to figure out my s? Square root of the sample variance. Very good. Now, my n, we said, was 26, and that gives me the information. So, again, it just wants to know, is there sufficient evidence that the bags are being underfilled? So look at your p-value. Is it low or high? Here it's high. Here it's greater than 0.05. So when you are on Hawkes Learning, it's going to give you the following two options. There is sufficient evidence to support the claim that the bags are underfilled. And there is not sufficient evidence to support the claim that the bags are underfilled. Those are the two options they are going to give you. You have to think critically. You have to do some logical thinking. We understand the P is high. P is high means the null must fly. We accept the null, right? You have to figure out, what does that mean in layman's terms? We accepted the null. So is there sufficient evidence or not to support the claim that the bags are being underfilled? No, we don't support that the bags are being underfilled. We're saying that based on this evidence, it's sticking at 419. So there is not sufficient evidence to support the claim that the bags are underfilled.